Hello students. So in the last lecture I was discussing about the bus interface unit of 8086 microprocessor, and there I discussed about instruction queue. So the next topic that I'll be discussing under bus interface unit of 8086 microprocessor is segment registers. So further going into the detail of segment registers, we need to know what is memory segmentation. So two types of memory organizations are commonly used. These are linear addressing and segmented addressing. In linear addressing, the entire memory space is available to the processor in one linear array, just as we have seen in the case of 8085 microprocessor. In the segmented addressing, on the other hand, the available memory space is divided into chunks called segments. As you can see, they have been divided into chunks. Such a memory is known as segmented memory. In 8086 system, the available memory space is 1 megabyte. This memory is divided into number of logical segments. Each segment is 64 kilobyte. In size and addressed by one of the segment registers. The 16-bit contents of the segment register gives the starting address of a particular segment. So as for stack segment, the starting address will be this. For extra segment, the starting address will be this. So the starting address of all the segments in the segmented memory will be given by segment registers. To address a specific memory location within a segment, we need an offset address. So if I need to access any memory location within a segment, I need an offset address. The offset address is also 16-bit wide, and it is provided by one of the associated pointer or index register, as I've already discussed about pointer and index register. So those pointer and I'm reminding you, those pointer and index registers are used for storing the offset address, whereas this whole 1 MB memory which is associated with 8086 microprocessor is divided into chunks, and these chunks are called segments. Each segment is 64 kilobyte, and the starting address of the segment is given by segment registers, and to access any memory location within segment we need offset address, which is given by index or pointer registers. So this is there I have mentioned everything that I've said. So I'll be discussing the segment registers briefly in my next slides. So what are the rules for memory segmentation? The segment can begin or start at any memory address which is divisible by 16, and the 4 segments can overlap for small programs. Now coming to the advantages of segmented memory scheme. So the first advantage is it allows memory capacity, that is memory addressing capacity, to be 1 megabyte even though the address associated with individual instruction is only 16-bit. So address is only 16-bit, and if we see 16-bit address, then the total number of memory locations we can access is 2 to the power 16. But in case of 8086 microprocessor, even the address is 16-bit, but we can access 2 to the power 20 memory locations, which is equal to 1 megabyte, and that is the advantage of memory segmentation. Second is it allows the placing of code, data and stack portion of the same program in different parts. So it actually facilitates use of separate it facilitates the use of separate memory areas for program data and stack. Third point, it permits a program or its data to be put in different areas of memory each time the program is executed. That is, program can be relocated, which is very useful in multi-programming. And the last point is the segment registers are used to allow the instruction data or stack portion of a program to be more than 64 kilobytes long. That is, it allows instruction code, data, stack and portion of program to be more than 64 kilobyte long by using more than one code, data, stack segment and extra segment. So this was all about memory segmentation. Now let's discuss what is segment registers. Now, as I've told you that segment registers are used to store the starting address of each segment of segmented memory. So basically, again let me discuss what happens. The physical address of 8086 is 20 bits wide to access 1 megabyte memory locations. However, its register and memory locations which contain logical addresses are just 16 bits wide. Hence, 8086 uses memory segmentation. It treats the 1 megabyte of memory as divided into segments with a maximum size of a segment as 64 kilobytes that I have already discussed now. Thus, any location within the segment can be accessed using 16 bits. So the 8086 allows only 4 active segments at a time, that is code segment, data segment, stack segment and extra segment. So for the selection of the 4 active segments, the 16-bit segment registers are provided by the bus interface unit of the 8086 microprocessor. So these 4 segment registers are code segment register, data segment register, stack segment register and extra segment register. To hold the upper 16-bit of the starting addresses of the 4 memory segments on which 8086 works at a particular time. For example, the value in code segment identifies the starting address of 64 kilobyte segment known as code segment. So the value in code segment register identifies the starting address of 64 kilobyte segment known as code segment. By starting address, we mean the lowest addressed byte in the active code segment. The starting address is also known as base address or segment base. So the various functions of segment registers are: code segment register holds the upper 16 bits of the starting address of the segment from which the bus interface unit is currently fetching the instruction code byte, that is code segment. Code segment register holds the upper 16 bits of the starting address of the code segment from which the bus interface unit is currently fetching the instruction code byte. The stack segment register is used for the upper 16 bits of the starting address for the program stack. So all stack related instructions will operate on stack. Extra segment register and data segment register are used to hold the upper 16 bits of the starting address of the 2 memory segments which are used for data variables and constants. So this is all about, as I have told you, in bus interface unit there are 4 segment registers, that is code segment register, data segment register, extra segment register and stack segment register, and each segment register stores the 16-bit of the starting address of the segments. So this is the segmented memory having 1 byte, and we have 4 active segments at a time, each having the size of 64 kilobytes, and the starting address given by the segment registers. These are the, suppose for stack segment, the starting address will be given by the stack segment register. Similarly, for extra segment, the starting address is given by the extra segment register. So I'm ending this class here. We'll continue with the same topic in my next lecture also. Thank you.